So we branched off. We talked about ApoE4, and we were sort of talking about how the model for Alzheimer's dementia has been wrong. So we talked about ApoE4, but bring us back into that and talk about how we perhaps have conceptualized age-related cognitive decline, Alzheimer's dementia that is not this, the early onset Alzheimer's. We differentiated those in the beginning, and then how we might create a better model for what's going on here.
Sure. So because of the original way that we understood Alzheimer's disease and the way that neuroscience really started was with pathology, neuropathology, right? So you take a section of brain, you put it under a microscope, and you take a look at it. And what we saw in classical Alzheimer's, and what you do see in multiple different neurodegenerative conditions, including age-related dementias, is these like pathological accretion of proteins. Like people have heard of amyloid plaques, tau neurofibrillary tangles. So these are two proteins that misfold or aggregate within the brain that can either be outside of cells, as you generally see with amyloid, or inside of cells, as you generally see with tau. And there is a point, and we see this, we think we see this in human data and then also in animal data. There is a point where once you've collected enough of these proteins, they start to be sort of damaging in their own right in a feed-forward manner. However, there's this like gulf in between where different people have vastly different amounts of these proteins, and they have very different cognitive outcomes or long-term cognitive trajectories, and the two almost don't correlate at all. So once you get to the end stage of the disease, yes, these are certainly involved, but it seems like in between they don't really make much of a difference. And we've seen this in multiple mouse models, that the amount of amyloid that you've accumulated doesn't correlate with outcomes. We see the same thing in humans. In humans, we can actively reduce the plaque burden, the amyloid plaque burden in your brain, but it doesn't seem to have any effect on your cognitive outcomes. And this is where billions of dollars of amyloid targeting therapies have gone by the wayside. And I've heard from some people that they think there's going to be a new study with aducanumab, which is going to show that all the naysayers are wrong, and actually it's going to be beneficial. But in general, there's no therapy targeting amyloid has been shown to be beneficial, and that amyloid plaque burden doesn't correlate with cognitive outcomes or trajectory of Alzheimer's disease. So then we started to focus more on tau, which may be a better predictor, and people are now talking about a dual pathway model where these things sort of like come together and interact. Other people are talking about something like a probabilistic model. So they're starting to take into account other factors. So then genetics becomes a factor, other environmental components become a factor. So we know sleep is important. We know that toxic exposure like air pollution is important. We know systemic health is important, like hormonal status, particularly in women during and after the menopausal transition. That's a significant risk factor. So we know all these things are important. And now, sort of the state of the art is to say, well, we can kind of, as all these things come together, the probability that you get dementia is increased. So, based on your hormonal status and maybe nutrient status, also very important. So some, really critical studies done by David Smith, who's an emeritus professor at Oxford. The Optima and VitaCog studies basically showed that if you have elevated homocysteine, so a level above 13, and you reduce that by giving somebody B vitamins, so particularly B12, folate, B2, and they have adequate omega-3 status, there seems to be an interaction, then you can significantly slow brain atrophy and slow cognitive decline. So nutrient status certainly seems to play an important role as well. And so at the moment, we're kind of like, well, all these things are important. And you'll have seen some models where, say the work of Dale Bredesen, which again has just been sort of fairly groundbreaking, and he's shown that in people with various stages of cognitive decline, you can reverse it by addressing multiple risk factors at the same time. So systemic inflammation, nutrient status, physical activity, diet, sleep, stress, all this kind of stuff. But it's a fairly complex process and very difficult to scale. You basically have to assess 50 different things at a cost of a vast amount of money and try and figure out, well, what's the thing that I should fix in this individual? And there is this still sort of very heterogeneous process that's going on. And all of that will be important if you want to like absolutely optimize or maximally minimize your risk of cognitive decline. Where we're going with this is the paper that Josh Turknett and I recently published, which basically sort of completely changes where we focus our efforts. And so all of the stuff that I just mentioned, I think is important. I don't want to discount it because I do think it's important. We have sort of interventional studies that show that, if we change stress or physical activity or nutrient status, we can reverse some aspects of cognitive decline or improve cognitive function in older individuals. But we start the paper by arguing that we're looking at the wrong biological level. Like, we're hyper-focused on proteins and mechanisms and in the cells, when what's probably most important is happening at like the organismal societal level. And what we suggest is maybe the most important both risk factor and then potential sort of mitigator of long-term cognitive decline is how and how much you use your brain. And so we liken it to exercise. And there's lots of evidence that actually shows that the way the brain responds to increased cognitive demands, and by that I mean, skill building, language development, sort of complex brain training, rather than I'm busy all day, my brain is busy. Those are not the same thing. But developing skills, that kind of cognitive demand, the cellular responses are very similar to how the muscles respond to exercise. And they respond by getting stronger and more resilient with more connections, and muscles do the same. And so the way to kind of boil it down is to say that, so imagine you, Costa Rica, great lifestyle, great food environment, no stress, not much pollution, right? You've optimized everything and you want to get stronger, right? You can eat all the protein you want, but you're not going to get bigger and stronger unless you actually stress your muscles, right? Mechanical tension is like king of increasing muscle strength. And I think the brain is the same thing, right? You could have this pristine environment where, even with, so movement helps. So, any kind of movement. So even though you're moving, you eat a good diet, you're not stressed, you sleep, how are you going to maintain the strength of your brain if you don't challenge it? I think the sort of the analogy works very well. So like a primary driver being how much are you really tasking your brain and asking it to adapt and be plastic and get stronger in terms of its connections and its resiliency. And the thing is that most individuals in modern society don't do that, right? We do the same thing every day. Our work isn't cognitively challenging. It's repetitive. Yes. It's stressful. Yes. But those are not the same thing. And so, we're not developing new skills. We're not asking our brain to do new things because we don't like being bad at stuff, right? Human adults in Western society just they just hate being bad at something and being seen to be bad at something. Yet that process of learning and failing is probably what is most critical for keeping a healthy brain. And I liken it to the brain developing in the first place. When you're a baby trying to develop your brain, you are constantly trying new things and you're constantly failing and falling over and not saying the words properly and interacting poorly and falling out of trees and all that kind of stuff. But as a result of that, you develop incredible motor skills, incredible language skills, incredible social skills. But we don't challenge ourselves in that same way as we get older. And with that, you get this trajectory of decreased cognitive function. And the easiest ways to see it is that when we retire, now there are multiple population studies that show that the earlier you retire, the earlier you experience cognitive decline or dementia. And that's because, in modern society, your work is probably the place where you're most cognitively challenged, even if it's not that challenging relatively. And as soon as you remove that, you're not going and then traveling and learning languages or learning to slackline or doing yoga, or at least most people aren't. You just go home and sit and watch TV and your brain just like, well, I'm not needing it anymore, so I may as well self-destruct. And there are molecular pathways by which that happens. So that's kind of what we've proposed, that the most significant protector of long-term cognitive function is how much you use your brain.
And I appreciate the way you differentiate between just being busy and doing something that's stressful and that occupies your time and doing something that really challenges your brain. When I was in medical school, I started learning jujitsu, and it was horrible. It was horrible. I hated it and I loved it at the same time. I never got that good, but I did it for a few years and I enjoyed it. And eventually my body learned how to move a little bit in those positions. But I could feel there was something going on in my brain. Sometimes after training or drilling, I would feel that my brain was sort of sore. It's like the Gary Larson cartoon, may I be excused, my brain is full. And then I did a little bit of training in stand-up martial arts like Muay Thai. I also never got very good at that. And I felt the same way. You just sometimes working on boxing combinations or something, I just couldn't get it. But I feel my brain doing that. The same thing probably happened with slackline earlier in my life. And I'm thinking about myself and I'm thinking, okay, now I surf every day, which helps me a lot because it's super challenging and I'm constantly trying to do that. And I live in Costa Rica, which has challenged me to be more and more bilingual. And in your paper, you mentioned that bilingualism is protective against cognitive decline. I thought, oh, this is great. I mean, my Spanish isn't perfect, but it's gotten a lot better being here. Mm-hmm. And languages feel the same way to me. And you mentioned that in your explanation there, that it feels like you have to try and fail. But you're right. I don't like being bad at things. It sucks, dude. I hate being bad at surfing, and I'm moderately good at surfing. I'm not great. But it's making me think that I need to constantly be doing new things that okay, I can challenge myself with surfing every day, but like, what am I going to learn next? Maybe it's more Spanish. Maybe it's another language. Is this how you would challenge people to think about things? Like, what are you actually learning now?
Yeah, exactly. And the important part of that being then, once you're good at something, you have to do something else, right? Because once something becomes habit or rote, or you can do it automatically, it's no longer a cognitive challenge. So I think one thing that most people will relate to, which is ironic because I don't do it, but is driving. It's hard. When you first learn to drive, it's difficult. It requires all parts of your brain, and you're continuously thinking, and everything requires input in order to do it. But then later on, it becomes automatic. So once it's automatic, it's no longer a challenge, and then you have to do something else, right? And then, but what I think is good, there is some specificity, right? So if you particularly want to improve the strength, the performance of your hippocampus or your memory related parts of the brain, then memory related tasks do have a greater benefit there. But in general, I think you can think about, well, what's a skill that I'd like to learn? And whatever it is you enjoy is probably something that you could do. So it could be knitting, or it could be yoga, or it could be a language. Maybe it's novel social interactions, right? Because for some people that can be a stressful or a skill to develop. So there's a whole bunch of stuff that you could do, and anything that you can spend sort of concerted time learning, but then requires a recovery period is where you think, well, this is probably the kind of thing that I need to do. So if it's something that you could do endlessly for hours and hours, it's probably not at the right level of challenge, right? If you think about learning a language, learning a new movement, some kind of coordinative type skill, you can probably only do it for 20 to 30 minutes in like a really concerted effort, right? So if you think about you're doing your jiu-jitsu level, lesson or class, you do some warm up and some patterns and that kind of stuff, but you probably only spend maybe 20 to 30 minutes to like really focusing on new skills, right? Because that's probably the time during which the human brain can probably have the capacity to just like really sort of push the edge and fail and get frustrated and all that kind of stuff. So those are the kinds of skills, but you could apply it to anything. So for me, I have spent a lot of time learning how to code. It's important for my job. It's like learning a new language. I'm not very good at it. It's very frustrating. But that's, again, a sort of a modern skill that I think counts. Yesterday I was interacting with somebody on a post about this paper, and they asked about video games. I don't think we have great evidence for video games because we're only right at the beginning of the generations that grew up with video games getting to the point at which they sort of start to be at risk of cognitive decline. But you have motor skills, reaction time, spatial memory, problem solving, right? a video game might give us a lot of those things. Of course, you might be sedentary for 8 hours at a time if you're
that's not good for your insulin resistance.
Right. If you're a really dedicated gamer, yeah, there are other things to take into account. But I think all of these things are relevant. How are you really challenging your brain? And there's multiple different ways to skin that cat. So you should just focus on something that you enjoy. But once you're really good at it, you have to try something else.
In the paper, you mentioned the blue zones. I was living on the Nicoya Peninsula, which is a supposed blue zone. People can refer back to our previous podcast about why the blue zones are kind of BS. But nevertheless, I think that there are some takeaways from the blue zones. One of the ones you point out is not the diet of the blue zones, which we know has been mischaracterized, or I think has been mischaracterized. I think you would agree with that, considering they eat meat in most of all the blue zones, except for perhaps Loma Linda, where they have hypoactive sperm. But they don't retire.
Based on the 3 people that they measured in that one study.
Yeah. Well, the vegetarians were low too. So we need a bigger experiment about Loma Linda sperm, is what you're saying.
Yeah, fine. You can volunteer to go and collect samples.
Well, I mean, mine won't be any different. I eat a lot of meat. I'm presuming mine work just great. Like you mentioned that in the blue zones, people don't retire. And I definitely see that here. I see people who work into old age. It's not a culture where the goal is to retire and sit on a beach. You support your family. And so into your 50s, your 60s, maybe even your early 70s, as long as you're functionally able to, there are men doing physical labor and women doing things that women do here, which is usually some sort of like selling things or cooking or, making things. It's just the societal way here. But I do see that here. And I think it's interesting that there isn't this retirement. It makes me a little worried for my family specifically, because my dad is now 72 and he's retired from medicine. And he has my niece and nephew. He has his grandchildren that probably keep him active and engaged, perhaps a little bit doing things, but it does make me, retirement is probably a really bad thing for humans, right?
I think so, as long as you don't, replace it with something else that's similarly engaging. Like, again, we, in the paper, we draw an analogy to the sarcopenia, or the loss of muscle mass you see in the setting of being either like bed rest, or say you break a muscle, or you break a leg and you put your leg in a cast, right? You don't move that leg for several weeks, and then the calf muscle on that side gets smaller, right? Because you haven't used it. And again, all the data support that if you stop using the brain, the same thing happens, right? Metabolic resources are redistributed. You don't need to support those same connections in the brain because they're not being used, and you'll start to pare back. And so you'll end up with something that we call cognitive frailty, which basically means that your capacity for cognitive function is only as much, is basically the same as you use it every day. There's no headroom, right? There's no capacity to do more if you wanted to. And then eventually you get so little capacity that you can do less, and then doing less decreases capacity, and you get this sort of feed forward cycle. So if you were to replace work with something that's similarly cognitively engaging, and it could just be that, right, you retire, but you take up learning Spanish and doing yoga, that's fine. I think that's probably going to do the trick. But again, in general, somebody might be like, oh, well, I retired, but I do the Sudoku every morning, so that's it. I'm probably good. That's probably not enough. It's maybe better than nothing, but it's probably not enough. So as long as you remain engaged, I think you will get, you don't have to worry about retiring, but you just have to be very, you have to be very cognizant and about that. If you can be, if your brain is still working.
I think Jordan Peterson has talked about the fallacy of sort of the sitting on the beach with the Mai Tai narrative that, most of us grow up, at least myself and the culture that I grew up in, thinking, oh, that's when you've made it, when you can just sit on the beach and relax when you're retired. But like, what the heck are you going to do? That's going to get boring so fast.
So my wife and I spent a week on the beach with Mai Tais earlier this year, and we may do it every year, but a week is enough. After that, I'm ready to do something else.
What beach were you at?
We were in Maui.
And you just drank Mai Tais for a week?
Something like that. 5 days. Yeah.
I can't imagine Tommy Wood just sitting around drinking Mai Tais for 5 days. You lifted weights. You did something else.
Oh,
You
yeah,
swam,
yeah. Oh, yeah. The hotel had a great gym.
but it was just relaxation.
Oh, yeah. Yeah, yeah. And
Okay.
sunshine.
Sunshine, of course, because Tommy lives in Seattle, which is not as, shall we say, solar radiation gifted as Costa Rica.
I mean, it's okay for like the 3 months of summer, but yeah, you're right. The rest of the time, it's not great.
So I had my vitamin D checked recently, and I'm pretty proud of my 75. 75. Although on a recent YouTube video, somebody said I looked sunburned. And I was like, okay, look, it's just, I'm really tan. Okay. I surf all the time. So I think that this is really interesting, and especially on the heels of really, I would say, the failure or the reimagining of a paradigm for dementia, which cannot be based on drug targets for amyloid plaques or tau fibrillary tangles, as far as we know now. Doing something that makes your brain hurt is critical. And we've talked about what those things are. Do you want to talk a little bit about nutrients as we wrap this one up? I mean, what nutrients are critical for brain health from your perspective?
Sure. So I think, and again, it's really funny. So we sent this paper around a lot. So first, before we published it, we sent it to like people we trusted to give an opinion, but who know the field well. And then it goes through peer review. And so we get some opinions from the peer reviewers. And then after it's published, we send it to some other people to say, hey, we published this paper. Like, what do you think about it? Because we obviously have this idea, but it doesn't become really meaningful until like people have kicked the tires on it. Maybe we've updated the constructs, like the model, better understood it, taking more things into account, right? This is by no means like the final answer, of course. And then you create some kind of model or theory. Ideally, we'd want to test it in some way experimentally. But every person who you send it to has a different favorite thing that they're like, oh, but what about this? This is also just as important. And so all these things are important. And I think the way I think about it is that the demands, the critical, like the challenge is like the most important thing. Everything else can be perfect, but if you don't have that, I think you can still end up with a decrease in function. But in order to respond to a demand, you need 3 things. One is adequate, nutrients and say vascular supplies. So you need good vascular health to provide enough oxygen and nutrients. And we know that if you have chronic vascular disease, that can sort of cause atrophy in the brain just because you can't respond to cognitive challenge because you can't. This is a thing called neurovascular coupling, which is where the neurons are more active, so they ask for more blood supply. But if you can't supply that because you have a vascular disease, right, then that's a problem. So good vascular health is important to actually supply the things you need, and then having the things that you need in terms of nutrients. You also want the absence of toxins that might prevent your ability to adapt. So that's where we think about pollution, maybe heavy metals, maybe infections and inflammation. Right, so you want all the nutrients and the supply. You want the absence of sort of toxic exposures, and then you also need time to rest and recover. So that's where sleep is really critical for dementia, and then also the absence of like a chronic stressor that doesn't allow you to really recover. So I think all of those things are required in order to adequately respond to the demand. There are a few studies that suggest that even in the setting of those things not being ideal, you will still get some benefit from demand, which is why I think it sort of has this prime place. The same thing being that, right, if you may not optimize your lifestyle and your sleep and your protein intake, but you'll still get stronger if you go to the gym, right? You could improve that, right? You could optimize that, but going to the gym will still be beneficial to some extent. So in terms of the nutrients, like you asked, I think we have the best evidence for the B vitamins. So there's probably something related to methylation, the 1-carbon cycle. So B12, folate, B2, really important for lowering homocysteine, particularly in people with certain SNPs.
Which is riboflavin.
Riboflavin, yeah.
Yeah.
And then omega-3 status is important as well. And for a long time, people thought that like DHA was going, the long chain omega-3 fatty acid was going to be like this panacea for Alzheimer's disease. And it hasn't turned out to be. probably because it's interacting with a few things, including B vitamin status and maybe insulin sensitivity. But those are the things that I think we have the best evidence for. So B vitamin status and then omega-3 status. So in the interventional trials, the best outcomes came from those who replaced their B vitamins or taking adequate B vitamins and had adequate omega-3 status. I think it was like the top third of people based on their omega-3 status. So there's some interacting effects and those are the nutrients that I think we have the best evidence for.